Okay, so open data ecosystems. I guess if not the main focus for yourselves at the moment, it's certainly a major one. I guess it would be good to start for those that don't know exactly what they are, how you define them, and also I guess why they're so important in terms of infrastructure engineering. And I suppose, today obviously we're talking about the water industry in particular. So what are they? Why do they matter to infrastructure, stroke the water industry specifically?
Sure, sure. Yeah, so the basic concept behind open data ecosystems is that the many products that are out there in the marketplace are able to speak to each other freely, so they can exchange information. In part, that's because our focus within Bentley is certainly a recognition that no single vendor can do everything that's needed. So it's really important that vendors in the industry be able to share that information so that data, knowledge, insights don't get locked into something by an individual vendor. And the second thing that really comes into that is not just the immediate exchange of information, but also thinking about what that means over the lifespan of the infrastructure itself. So infrastructure is meant to last. And when we think about digital twins, the digital representations of that physical infrastructure, we want to make sure that the digital twin actually outlives the physical infrastructure. And so the best way to make sure that this data is still available to be used, to be leveraged over the 50 years, 70 years, 100 years that the infrastructure is likely to be there, the best way to make sure that's still accessible is to make sure that it's open, that it's available for people to access their own data.
And so I'm just wondering, I mean, I've been involved in sort of technology industry, software, etc., for many, many years, and proprietary was always the, proprietary versus open. So are we pretty much putting proprietary systems to bed now? Is everyone pretty much signed up to open, accepts open as the way forward, or do people still have to be vaguely cautious? They might get sort of locked in if they're not careful.
Yeah, there certainly are some vendors that are not as open. Some of that might be legacy, and some of it might be a strategy to try to lock in, particular users. That's certainly not, I think, in the best interest of the users themselves, and really not in the best interest of those companies. I think anybody who still has a sort of a locked up proprietary format is going to find that the marketplace is going to shy away from them as they realize, just what that means in terms of being, held hostage to some extent to a given vendor. So I think I wouldn't go so far as to say, oh, today everything across the whole world is open and accessible. But I think you're going to see certainly more of a trend in that direction. But that's been somewhere that Bentley's been since its very beginnings. Literally decades and decades ago. Bentley's always had a strong focus on that openness because there's always been a recognition that, hey, this is going to be around for, like I said, 50 years, 100 years, or longer.
And in terms of the sort of developing that strategy most recently, I believe you've acquired a company called, I think, is it Cesium? Is that how I pronounce it? So
Mhm.
please tell us a little bit about the background to why that, acquisition is important to you.
Sure. Sure. So the Cesium acquisition, really, there are sort of two parts to that. One part is just the sort of inherent geospatial nature of what that brings. And that kind of aligns with the idea that every piece of infrastructure belongs somewhere on Earth. And so the ability to, locate that, to be able to see that in the context that it sits in, is just sort of, naturally helpful to anybody that's working on it. Another piece that brings, though, is the idea that that visualization, being able to stream that information, visualize it, make it more accessible, actually brings more stakeholders to the table. So you can actually reach a broader audience. You can take things where people looking at 2D maps, even if they're colored, or even a static 3D model, that just doesn't necessarily align well with the way the public understands infrastructure or doesn't understand infrastructure. And so being able to bring some of the Cesium tools to bear, helps make that, again, more accessible to a broader audience.
Okay, and I guess in a similar vein, you've also, I think, announced a partnership, or you are indeed partnering with
Mhm.
Google. So clearly, a name that I suspect very few people are not aware, unaware. But what are you doing particularly with them in this space?
Yeah, so you're absolutely correct. The Cesium acquisition and the Google partnership are both part of that same sort of direction in terms of the geospatial context of what we've got. Being able to integrate with Google's high quality geospatial content and integrate our Bentley's infrastructure engineering software and digital twin platform really helps to bring together these different types of information in a way that can really help improve the way infrastructure is designed and built and operated. And so bringing those things together, suddenly we've got more capability to open up additional AI capabilities, more analytics. The cloud technologies in general are a great way to be able to reach again a broader set of people. And so these partnerships, the partnership with Google really complements that acquisition we did with Cesium.
Okay, and if everyone's familiar with a name like Google, I suspect even more people are familiar with AI. The world is talking about it, whether it's domestic use, business use, etc. So in terms of that, for yourselves and your customers, I mean, you mentioned digital twins, and I won't say that it's mature technology, but I guess most people are probably familiar with the idea. I'm just
Mhm.
wondering what more can you do with that, but also what other possibilities does sort of what's going on with the AI at the moment, what else does that bring to the party? And again, I guess particularly with reference to the water industry.
Sure, sure. So yeah, so if we think about things like the Cesium acquisition and the Google partnership, like we just talked about, a lot of that is about accessing additional data. But beyond that, the intent isn't just to access it or just to visualize it. It's also about making that data more meaningful and more useful. And that's where some of the things like AI tools can come into play. So from a standpoint of what that brings, if we look at something like the advances we've had in sensor technology and automated meter reading and things like that, that's great, but on its own, some of that data can actually become overwhelming for a water utility, for example, where if we looked at them 10 years ago, they might have been starving for information, blind to a lot of what was happening, and now suddenly they're drowning in information. And so AI can help to process a lot of that data, so helping to identify patterns that exist, maybe faster than a human would be able to, or being able to monitor some of those data streams and be able to catch things that otherwise a human would have to go in and maybe only be able to check on every few days or once a week or something. The AI can be running in the background and kind of looking at those things and flagging things so that a human can take note and look in more detail and try to see what's happening. So that can help as well with not just the identification of patterns and so on, but if we look across infrastructure, but definitely the water industry specifically is definitely struggling from a resource standpoint, right? The sort of brain drain as a lot of people who've been at the utility for a long time retire, and not a lot of people always coming in to sort of take their place. And so how do you try to run these complicated systems that are ever expanding while you're losing staff and dealing with fewer people? And that's an area where AI type of tools can really come in and be more helpful. Again, not outright replacing what an engineer does or what an operator does or anything, but being able to um, uh, do some of that monitoring, do some of the analysis, provide some of those insights, and really be a co-pilot to the engineer or to the operator to help them focus on what's most important and apply their own skills to that.
And I'm just wondering the potential for it long term. I know some industries talk. I do a bit of work in the data center industry, for example, and they're all talking about the sort of autonomous lights out data center where sort of AI will basically run the whole thing. I mean, is that at all likely in something as complicated as a water supply network or wastewater that eventually you'll be able to trust the AI to not only spot patterns and maybe anomalies, but also to take preventative action before a human being sort of is even
Yeah.
aware of what's going wrong, or is that a little bit sort of sci-fi? What's the reality, I suppose?
I'd say that ultimate idea that humans aren't even involved, it's totally hands off. Maybe that's in our distant future somewhere, but I do think that's a little bit sci-fi at the moment. The parallel I would draw is maybe if you think about the way the human body works, you've got sensors in your fingertips and so on, and there are certain things where if you touch a hot stove, the automation knows to pull your hand back before your brain's had a chance to think about it. But ultimately, your brain is still, making the decisions about where to move your arms and what to hold on to and what to let go of and so on. So I would see this being, something along those similar lines where we'd say, yeah, there's going to be some level of automation for, making sure that certain things, maybe shut off or go into a shutdown mode before they cause huge damage or before something like that happens. You already see that to some extent with automation in treatment plants and things like that. But overall, the higher level planning and the higher level operations to say, well, how am I going to make this whole water distribution network, this whole body, how am I going to make it work together? There's certainly an opportunity for the AI to make recommendations, to see, patterns that again the human might not see right away. But I think we're quite a ways away from a human not, at least reviewing that information, taking it into account, possibly applying other judgment that's maybe not even captured electronically at this point. I think we're still a ways away from the human being not being directly involved in those sorts of things.
And just before we come on to some of the sort of Bentley latest developments, in terms of the water industry, it's perhaps not got the greatest track record when it comes to deploying IT. It has a lot of sort of well, historically almost incompatible and old-fashioned legacy bits and pieces. Is that any kind of an obstacle when it comes to AI? Interrogating all this, latent legacy data is a particular challenge for the water sector, or not? I guess is the simple question.
Yeah, there's always been, I would say, an appropriate hesitancy within the water industry to just outright kind of blindly accept new technology. And that makes sense because when you think about it, if you're not running your water system the correct way, you can end up literally killing people, right? If your treatment's not done right, if you're distributing water that's not cleaned the way it should be, there are some pretty significant repercussions of not operating those systems well. But I think what a lot of the utilities we talk to, at least, what they're realizing more and more is there's also a risk associated with not adopting technology, right? And so the idea that, oh, if we're not getting smarter about when we're operating our pumps, that has an impact on our electric bill and on our carbon footprint and maybe on our service. If we're not getting smarter about simulating the flow of water and understanding the water quality characteristics and how that changes as it moves through the network, if we're not getting smarter about that, there's actually a risk that we've got contaminants growing in the system that we're unaware of. And again, if we're not doing work with technology to build up digital twins and sort of capture the enterprise knowledge in a way that can outlive our aging and retiring staff, there's a risk associated with that as well. So there is still, again, I would say, an appropriate hesitancy is not quite the right word, but I'll use that word. An appropriate hesitancy to just say, hey, we're not going to just say, oh, this is a shiny new object, let's throw it in, let's start doing it. No, of course not. But more and more, there's a realization that, there's a lot to be gained by applying technology. And if we do it thoughtfully, if we start with the data we've already got and the people we've already got, there are some very clear and very safe ways to move ahead with it.
Okay, and in terms of the ways in which your cells are able to help the water industry, I guess most recently developments, think you launched or introduced the OpenSite Plus solution. So
Mhm.
perhaps you can tell us a little bit about that, obviously what it features and I guess particularly the benefits that it brings for users.
Sure, sure. So, as you might guess by the OpenSite Plus name, the focus of that is anything that deals with site engineering. So that could be something like a hotel or a shopping center or something, but it could also be a site like a water treatment plant or a pump station or an elevated storage tank site or things like that. There are a few different parts that go with that. So that it is an AI-based offering. And so one of the parts of that is the natural language side of AI. So the ability to, ask a question, whether that's typing it or speaking it, but asking a question in natural language to say, hey, can I, how far away from the property edges do I need to build my structure? And having the AI be able to go and search the zoning records and things like that or whatever, and say, oh, you need to be 50 feet from here and 200 feet from the road, or whatever it comes back with there, and citing the sources of that as well, right? So you can always trace it back, and it's not just an answer coming back that you hope is right. It's an answer that comes back and says, oh, we got this from this document on this page, this specific line. So the natural language part is again part of making it easier for people to interact with and making it so that you don't have to think like the computer. The natural language model helps the helps the computer translate from your thoughts. Another part of it is then really more the technical side of this. So saying, hey, if we are trying to put a treatment plant here, or maybe we're trying to extend this treatment plant to add another train or to add some additional capabilities that weren't there because of stricter regulations or things like that. Where can we put this in a way that sort of optimizes the site? How can we do this so that the amount of earth we have to move around is minimized, or understanding the impacts that has on the drainage for the site. And it really starts connecting the dots between, a lot of these sort of interrelated pieces of what sounds like a simple effort to create that site. So that layout optimization then, really helps to kind of, again, orient things towards how this could go. And maybe there are several different scenarios you could look at for that as well, right? So looking at things and saying, hey, it's not like the AI is just going to spit out one thing and it's take it or leave it, right? You can make adjustments, or you can look at different options. And again, kind of, the engineer can focus on whether or not this does what I'm intending and whether it works, not have to focus on, all of the 100 steps to go through and move those pieces around. Um, and then finally, the other part of it really is then the kind of taking that and doing the automated drawing production side of it. So you've got everything the way you want. You need to make sure that it's ready for somebody to actually go bid on it and construct it and so on. And so the AI can actually take that, and a lot of places still use, you know, I'll say paper sheets, but it might be an electronic equivalent to paper, but spitting out those all those different drawing sheets and things like that. Well, normally that would take a person forever to go in, maybe even several draftsmen that are going in and working the different parts. Well, now you don't have to waste time having people go with the drafting. The AI can help you spit that out, and maybe you still have some drafts persons that are going to go in and again check it, maybe tweak it. Right, it's not necessarily completely hands off, but it can really, really reduce the amount of time that goes into the manual effort. That's not a whole lot of value add, right? There's not a lot of the value add isn't in the idea that you came up with a drawing. The value is that you were able to actually make your treatment plant function better and put it on the piece of land that you have to work with.
And I'm guessing to the point you made earlier as well, I mean, you might have a very experienced engineer on one of these projects, so he potentially or he or she knows most of the things to think about, but even then it can speed up that process. But particularly, say, with less experienced folks, there's a lot of help there for them. So as you say, so they don't have to, if they've not got the knowledge, carried around in their head, it will help them. So it will just speed up the process regardless of, but particularly for, shall we say, less experienced
Yeah.
engineers. Is that fair to say?
Absolutely. And I think one of the important things that you're touching on there too is the idea that oftentimes we think of digital twin as being a representative of what your infrastructure is today. But one of the real benefits of it is being able to imagine what it will be in the future, or imagine different scenarios of what it might be in the future. It's relatively inexpensive to make a mistake in a digital model, right? If you try something and it doesn't work, you haven't killed anybody, you haven't wasted millions of dollars, right? A little bit of time, and you've gained some knowledge through that mistake. That's a lot different than getting out into the field, going to actually construct something and realizing, oh, this doesn't work, or oh, this, we do have to move a lot more earth than we thought, or oh, the drainage doesn't work correctly. So the ability, and those are, oftentimes younger engineers discover that by making a mistake in the real world and suffering the wrath of their superiors. This is something where, again, being able to experiment electronically, try different things, learn different things, can really be a much more efficient way, and much less wasteful in the real world. So you can kind of guarantee that your real world efforts are going to be closer to what you're trying to obtain in the first place.
Okay, and I think one other thing that I came across, you hopefully you can tell me a bit more. You believe you've introduced some carbon analysis
Mhm.
capabilities. So I can't remember if that's a specific new product or you've added that to existing, program. Just talk me through what's been going on there.
Sure. Yeah. So the carbon calculations are something that really sort of extend the capabilities we already had related to a lot of our tools that are oriented around building new infrastructure. So these would be things where you can actually look at sort of the carbon impact of, if I build a concrete wall this thick, or if I build a wall this thick, or if I use steel instead, being able to understand the impacts that those decisions have on the carbon footprint of doing that. Quite honestly, that's important for anything you're constructing, and certainly again, in the world of water, we're constantly building new treatment plants and pump stations, and burying new pipes and things like that. Um, but actually, for decades, we've had energy costing and carbon calculations associated with things like pumping, being able to identify if you're doing something like choosing a new pump to go into your water network, looking at things like what your system head curve is like, and therefore what pumps would have the best efficiency points to choose against it, and understanding even things like how would you schedule your pumps to turn on and off in a way that's the least wasteful. Um, Again, one of the challenges of the water industry in that regard is, well, the best way, you could reduce your carbon footprint entirely if you just never, your operational carbon footprint if you just never pump. But that doesn't really meet the primary objective, which is, get water from here to there. So within that, though, being able to look at things like what the energy usage is for those pumps, and again, how you want to schedule those pumps, is something where you can help to significantly reduce your carbon footprint. And also, of course, by reducing your energy usage, that also means that your electric bill goes down too.
I'm just wondering how granular that is. I mean, because clearly the life cycle of products, components, whatever is important as well. So are you able to sort of start from where they've come to where they might end up? Is that, or do you only look at the sort of bit from when they arrive on site, shall we say, or how comprehensive is that sort of carbon analysis, I suppose?
Yeah, so for the construction side of carbon analysis, um, really that's looking primarily at new construction, right? So looking at this and saying, hey, if you've already built something, okay, that's great. We do have some tools from a building standpoint that can look at the energy efficiency of the building, and look at that. But the newer tools that we've introduced are primarily related to what are the materials that we're bringing in, and how are we assembling those to make something new. On that energy consumption and pumping side, sort of the operations side, again, those tools have actually been around for decades. They're well used. We've got lots of user stories about people saving a lot of money with it. And for that, certainly you can start with what you've already got. So in fact, one of the things that a lot of our users do is if they're creating simulation models of their networks, if you just go to a pump station and look at the pumps, you don't really see much, right? You can't see inside the pipes, you can't see the impellers, you can't see the water moving. It just looks, one pump looks exactly like another pump. But by using some of the analysis tools, you can actually start to realize, oh, this pump is operating inefficiently, maybe spinning and spinning and spinning, but not actually moving any water anywhere. We can help identify that. And then our users can look at that and say, well, how am I going to change the operations so what I already have works better? Or if I've decided that I actually do want to replace this pump with something that's going to be more appropriate for the job I'm trying to do, how do I select a pump that's going to work best for the range of scenarios that it needs to work over?
Okay, and those I think announcements you made at your I can't remember, it was late last year, wasn't it? You have your annual
Mhm.
conference, and in part of that you celebrate the winners of, I think, is the Going Digital Awards.
Yeah.
So I'm sure there's a detailed case of, but can you at least give us a flavour of the wastewater winner? I think was it State of Sao Paulo and Sabes, is it Sabesp or Savies?
Yeah.
I'm not sure how to pronounce that, but just what was that project? Why was that the winner? I suppose is a good question to ask it.
Yeah, yeah. So the Sebest project was the winner, and really what they were doing was they were taking their responsibility covers hundreds and hundreds of municipalities in Sao Paulo, Brazil. And so what they were doing is they were taking this and they're trying to integrate all of their water supply and sanitation data into a single environment. And so they called that Integra 4.0. It's this program to bring together all this data that they've got from these hundreds of different things. And then by combining that, they were able to do a better job of modeling the hydraulics of how these systems work. They're able to monitor leaks better, so they can actually see when water is disappearing from their system, and they can go identify that and address it. They're also able to get better access to all of that data for all of their different colleagues across lots of different roles within there. So again, IT professionals, engineers, operations people, right, being able to pull that together in a way that everybody can access the data that they need. So that doesn't necessarily mean that a customer service person answering the phone needs to suddenly know how hydraulic models work. By bringing the data together, though, it means that they can actually benefit from some of the engineering insights and recognize maybe some of the things like flows and pressures that they might not otherwise be able to see. And so by doing that, even just in the first half a year or 7 months or something like that, I think they had already been able to reduce their water losses by almost 30%. They had already saved upwards of 3 million Brazilian lira, which I think is somewhere around 500,000 or so US dollars. They're already reducing the amount of time it took them to identify and locate these things, and thousands of hours of field work. Um, and of course, when you're able to go in and fix you know fix leaks and do things like that, every drop of water that doesn't leak is a drop of water that you didn't have to collect, you didn't have to treat, you didn't have to pump, right? And so they've got some additional efficiencies that they gained through that as well.
Okay, and that's a sort of nice little segue into the couple of sort of more general questions to finish with. We're clearly the water industry sustainability is sort of front and center. There's
Mhm.
climate volatility, if we call it, so it tends to be, extreme events, floods, droughts, etc. I'm just wondering, in terms of the wastewater infrastructure, and resources more generally, what do you see as Bentley's, role, or how can you help the water industry address what are significant challenges? I mean, already in parts of the world, there's
Hmm.
serious sort of stress from certainly from lack of water, and even dare I say in the UK where it's raining today and it always rains. The prediction is that within a decade that demand may well outstrip supply, etc. So there's quite a sort of impending crisis, however you want to characterize it. Just how do you see Bentley's role within that developing
Yeah.
picture, if you like?
No, yeah, you're absolutely right. The challenges are everywhere. Every community maybe has a different set of challenges or a different prioritization of what they're trying to fix. But yeah, even places that have traditionally thought of themselves as having plentiful water, are finding themselves suddenly scrambling to try to deal with drought for the first time. And places that have felt like they were relatively, safe from, flooding, are suddenly finding that they're dealing with, more storm water than usual, and the impacts that has, and so on. So our role at Bentley really is around providing tools that water engineers can look at, and water operators can use, and so on, to look not only at what they already have, but look to that future and enable them to play out those different scenarios. So if you think about that, where we are today, what is the world going to look like 20 years from now, 30 years from now? It's really hard to know, right? It's really a matter of, it's an unknown, right? It's the future. So the best thing that an engineer can do today is make sure that they're not designing for some imaginary fixed point in the future that is probably unlikely to pinpoint, right? The best thing you can do today is make sure that you're actually building in flexibility so that whatever happens in the future, you're able to adjust to it and adapt to it, and you can still do what you need to. And so a lot of that has to do again with that sort of scenario evaluation to say, there's a likely range that we'll be within. But what if we're on this side of that range? What if we're on that side of that range? What does that mean? And how do I choose something today so that, again, if I'm building a piece of infrastructure today that's supposed to last 50 years, how do I make sure that 20 years from now, if the world has changed and I need it to do something a little bit different, how do I make sure I can make those adjustments and not just have a wasted piece of infrastructure sitting here for another 30 years, not doing its job efficiently? So our job as Bentley, again, comes back to how can we provide better tools to help engineers look at that range of conditions that they're likely to be working with, that range of possibilities, help them evaluate different options for what they can build or what they can do, and then make the best informed decisions they can.
Okay, and then just finally, year ahead, looking forwards for yourselves. I expect there's things under wraps that you won't want to talk about until they are announced, but just sort of the general direction of travel. What are the likely sort of things we can expect from yourselves as the year
Yeah.
progresses and a little bit into the future? Where your focus might be, shall we say?
Yeah, well, all of your, I think all of your questions to this point have kind of led towards that, right? So we've already touched on kind of that geospatial aspect of things. We've already touched on a lot related to AI, and even touching on the carbon footprint stuff, and even just the general approach that we've got. So if you're looking ahead and wondering, oh, what is Bentley going to be focusing on for the next several years, or probably for its lifetime as a company, it's going to be any of those things that can help infrastructure professionals make better informed decisions. And so there are aspects of that related to planning and design, where you can sort of, again, imagine different possibilities for what the world might look like decades from now and try to build the most resilient infrastructure. There are decision improvements you can make today related to the constructability of that infrastructure. And we'll do more and more to try to connect the dots between the planning and the design, and the actual building of the infrastructure itself. And there's also, again, a lot more potential when you look at taking that original engineering knowledge for why the infrastructure was built this way in the first place and bringing that into operations and maintenance. there's a lot of benefit that can be done by making that engineering knowledge accessible to non-engineers who are trying to run these pieces of infrastructure on a day-to-day basis. So all the technologies, AI and so on, technology for its own sake might be a shiny object, like you were saying, but that's not the point, right? The point of the technology is really to provide those better insights, which leads to better decisions, which leads to better infrastructure, and that's what we're going to be focused on for as long as our company exists.
Okay, oh, it's been brilliant to chat. You've given me a lot of time, so appreciate that, Greg, and we've covered a lot of ground and some brilliant insights into what's going on at the company Bentley and also more widely in the industry. So thanks for your time. Appreciate it. Thank you.
Yeah, absolutely.